Looks good. All right, so welcome everyone. Thanks for joining us here. My name is Brett Neuman. I'm a consultant in the Consulting Services Group. That's in the HPC division. I think the goal of today's discussion tutorial here is to just really cover the basics, avoiding some of the complexity of using the resources here at NCAR. Just get you familiar with logging into the system, how to check your account status, what the software stack looks like, what you might want to do if you need additional software on the supercomputers. So I encourage anyone here, just if you have any questions at any point, feel free to ask them here, raise your hand, or you can type in the chat. We have someone on my team monitoring the chat, so hopefully they'll be able to interrupt me and we can handle those questions as they come in. But if we want it to be interactive, that would be great. But yeah, anytime, any method you want to ask questions, feel free. So just to go over an outline, it looks like we actually following along. All right, we'll see if that's a little bit better. Move the mic closer. It is on. Okay, well, I think this will work. Just want to make sure that. Yep. All right. So for our outline here, what we'll cover for the topics today, we'll start going over just the different HPC systems that are available at NCAR. We'll talk about how to actually query your account status, the projects you have. We'll talk about some of the spaces when you log into the systems, where you can store files, what the different file spaces are used for. We'll talk about what's available for the software, if you need to add different software, if you want to run Python programs, those sorts of things. We'll also talk about different ways to actually launch jobs on the compute nodes. There's interactive and batch node jobs, and there are different types and how to start those up. And we'll also talk about some of the data and visualization tools that we have available here. And finally, and I think as we go on, there'll be additional resources that you can look at. I think that's one of the priorities here, is to be able to give you all the opportunity to explore these in more detail, and I'll provide some of that information with links in the slides here. So here is an image of the NWSC, or the NCAR Wyoming Supercomputing Center. And you'll probably have heard already or noticed that there aren't any of the supercomputing systems here in Boulder. So they're all located up in Cheyenne. And nice overhead view of this building here. And this was finished in 2012. This is kind of a state-of-the-art data center that they created here. And some of the infrastructure and the power requirements of the modern supercomputing just required us to move from the Mesa Lab data center to the NWSC. And it's pretty unique in that it's really focused on renewable and sustainable materials for the building. It's won quite a few awards, so their Green Data Center Award in 2013. Uses some pretty cool natural cooling. There's a water tower, which you kind of see on the right side screen here. And they use some of that to actually like native landscaping for some of the water requirements of the data center. So 10% about of the electric power from wind. And there's also now some new data centers that are popping up around the NWSC, and they're using that as a blueprint for how to design their data center. So pretty cool. If you get the opportunity to go on the NWSC tour, highly recommend it. They know a lot more about it than I do and can talk about some of the really cool technical details. It's a very cool place to check out with a lot of cutting edge technology. So just to give you an idea of the power requirements and just why we had to move to the NWSC, you can see on the x-axis it's over the years, and on the y-axis here you've got megawatts, so power utilization of these systems. And there's a red line here of the Mesa Lab computer facility. and the maximum energy that you can use within that facility. So there had to be a change here. And you can kind of see here Yellowstone, which is the yellow color on this chart. That was the first system at the NWSC, followed by Cheyenne, which was just retired last year. And now in the kind of teal color, the farthest to the right is the Derecho, the newest system, which we'll be talking about the most here. You can kind of see there's that spike on the initial setup. If you look at the y-axis, that comes out to about powering 2,200 homes. Is what that initial setup, and it kind of settled back down into the powering about 1,500 homes, just to kind of give some context on how much power is utilized on these systems. There's some, if you don't get the opportunity to go to the NWSC, there's a lot of work that's been done to make virtual tours. So you can follow these links and kind of check out some of the data center rooms and the exhibits that they have available at the NWSC. I think I'll use this slide to talk a little bit about the philosophy, maybe a little bit about the history of these machines. So you can see there's a picture here on the top left of Cheyenne, which was the last supercomputer that we retired. That was in January of this year. And just to give you an idea of the differences between the computer architecture and the number of nodes between these systems, you can see Cheyenne here. There were 4,032 CPU nodes, 145,000 cores, and then comparing that to Derecho, which is over on the right here. What we actually have here on Derecho is 2,570 nodes and a lot more cores, so 323,000 cores, so more cores per node on Derecho, and that's the big difference. And so what we calculated this out to with benchmarking is you get about a 3.5 times performance increase compared to Cheyenne. There's also a portion of Derecho that's our GPU node that uses NVIDIA A100 GPUs. We'll talk about the specs of Derecho a little bit more on an additional slide. Compare that to Casper, which is our data and visualization node. It used to be called DAV. So if you ever see DAV in any of the documentation, then you know that's actually referring to Casper. But that's more of a heterogeneous node and node structure. And what that means is that not all of the nodes are going to have the same type of technology in them. So they'll have different GPUs on them. They'll have different CPU architectures. And I'll talk about how to clarify, like which type of node you want to request when we start looking at the job submission information here. So the big difference that at least I think about when you're going to use either Derecho or Casper is that we think of Derecho as the big supercomputing system. So things that you want to run big climate models on. So something like CSN or WRF, those are the applications that you would want to run on Derecho. And I would ask myself the question: if you're going to run on Derecho, or you're going to run it, like how many nodes am I going to use? That might be the use case where you'd say, okay, I probably want to run on Derecho. If you were going to look at running something on Casper, you might ask yourself the question: how many cores am I going to use? And this is just kind of a rough way to think about the differences between the two systems. So like Casper, for example, runs a lot of our like Jupyter Hub and visualization tools. So just to give you an idea, depending on what project you're working on, which system you're more likely to utilize. And then just on the bottom, kind of separate to this, if you go to the NWSC, you'll see this is a separate file system that we have set up. And this is our Glade storage system. And this is something that's available across, well, most of the file spaces are available across all of the supercomputers. And I'll go into a little bit more detail in the file space following slides, but there's a lot of space available to you on these systems. So here's a really cool shot of Derecho. This is with the front panel art included. This is when it was completed in the NWSC here. So a little bit more detail into the actual architecture of the HP Cray EX supercomputer here. This entered production. There was some scientific discovery applications that ran in June of 2023. And then we made it available to everyone in August, which we were able to verify functionality of the system. So this is AMD EPYC Milan processors. So about 256 gigabytes per node of memory. And this also uses the Cray Slingshot Dragonfly network. So that's a proprietary network structure. So some of that information is hidden behind, I think one of the SciParks projects is going to explore some like the benchmarking and capabilities of the Slingshot network, which is pretty cool. We're pretty interested in figuring out more about that. There's also the 82 GPU compute nodes. So if you want to run a GPU-specific workflow, Derecho does have a subset of nodes available to run those. So those are A100s. Those are connected up directly to the network. When you log into Derecho for the first time, you're also going to have 8 login nodes available to you. We'll talk about those as well in a couple slides here. So this is the back. So this is kind of giving an idea of the cabling that's required to get this all set up and working within the data center. And it's pretty complex. You've got connections to different nodes and to the file system. Looking at Casper, I'll just break down the different node types real quick here. There's 75 of the high throughput computing nodes. And so a lot of these nodes are CPU specific workflows. If you have something that's only going to require one core or a script you want to run that actually might use a lot of the CPU, this is probably the target you would go for. We have a couple options for nodes that have a lot more memory on them. So if you have a problem where you can't split it up across multiple nodes, but you need a lot of memory, we have a few nodes available for that. We have 9 nodes that are dedicated to data analysis and visualization. There are a couple tools to help with that, but those use a slightly different type of GPU that wouldn't be as good for things like machine learning or AI type workflows. But then we do have the 20 nodes that would be appropriate for that sort of workflow. These are going to use V100s, A100s, and then we actually now just set up 2 H100 nodes that are available to you. So the one thing with Casper is that when you request a job, an actual compute node to run your job, you do need to be clear about what type of resources you want. Typically, if you aren't, you'll get a node and it'll run your workflow, but you might not have the exact type of architecture that you would want. Or if you wanted to run the same code again and want reproducibility, like numerical reproducibility, you might want to specify what type of node you want on Casper. So I'll pause for just a moment and see if anyone has any questions about that, or we can move on to systems account manager.
Yes, so we have 2 large memory nodes available for Casper. So what sort of like use case scenarios that can be used? That 2 nodes only for visualization, or you can also use them for numerical computation for some, or like, are there any restrictions on?
There are no restrictions on them.
Okay.
I think determining which node to land on, if you have a problem, I think the most common scenario here would be a situation where you aren't able to split up your problem using MPI. And you knew that you needed those high memory nodes, then you can specify, but there are no restrictions whatsoever.
Nice. So a follow-up question, in terms of core hour usage, are they would they cost similarly to like a regular node, or like they will be like at a premium price?
No, that's a good question, and I'll talk about the queue structures a little bit more, but the way that those are set up for core hours and how it counts against your project allocation are different between Derecho and Casper. That's something definitely to be aware of. For Casper specifically, it's going to be by core hours. So for example, if you launch a job and you use 4 cores, then it's going to use those 4 core hours. And that's kind of across the board for Casper, but for Derecho, this is also why I mentioned something about the philosophy of being how many nodes am I going to request. For Derecho, if you started a compute job requested 1 CPU, the way Derecho is set up is actually you will get charged for using the entire node. So there are 128 cores on the node. You'll actually get charged for 128 core hours. And so that's why we generally promote, if you're going to use like scripts or single CPU workflows, like Casper's really the target you want to be going for. Just to be aware of that, yeah.
So it doesn't matter how many CPUs you use when you're using Derecho. Even if you use 1 core, you'd still be paid for 1 node.
Yes.
What you were saying.
Yes.
I see.
And I mean, you can think of it, like I said, in multiples of 128 cores. Because if you request multiple nodes, then that's really the type of workflow that we want on Derecho. Are those ones that are going to really utilize 128 cores across the nodes. There is actually a separate queue on Derecho, but it's somewhat limited. there's what's called a main queue and a develop queue.
Mhm.
Develop queue is actually a shared queue, and it operates the same way as Casper, where you only get charged for core hours. But I believe you can only have, I think it's a limit of 256 cores, only one job running at a time, and a wall time limitation. So there are limitations within that system.
And also, do they have any limitations on how much memory you have on each core?
No. There's none.
Okay, thank you.
All right, so click nothing online. So moving on to Sam here. This is more of an accounting site where you can get an idea of, certain jobs that you ran, how many core hours those used, how many core hours you've used in the month. So there's a reports page that you can check and see your 30 and 90-day utilization of the system. But really, it's more just about the user settings when you're logging on to these systems. So sam.ucar.edu, I encourage you to check that out and kind of get familiar with that. You can also check change your default shell if you're interested in doing that. Sam here. So this is part where we'll do it sort of interactively here. But first time, if you want to try logging into either Derecho or Casper, this is the command that you'll use. So just using SSH, if you're on Mac, that's the terminal. You could use VS Code. If you're on Windows, PuTTY, MobaXterm, something like that. The command would just be SSH-Y, entering in your NCAR username and then add derecho.hpc.ucar.edu. And I'll go, first I'll just say, once you log in successfully, you'll get placed randomly on, if you're logging into Derecho, it's one of 8 login nodes. It's round robin, so it'll be random which one you're put on. For Casper, there's 2 login nodes, and you'll see you'll get put on one of those 2. So here's the example of what'll happen once you log in for the first time here. It'll ask you for, it's actually, I think, an NCAR 2-factor. I see the question in the chat. So -X, if you're on a Windows machine, that'll be the way to use X forwarding in the SSH, where -Y would be the Mac version. So the type of response, it'll actually be, I think it's NCAR 2-factor will come up, and that's where you enter in your NCAR password. Once you enter that in, you'll receive a push on your device and accept that, and you'll actually be on the system here. If you do run into any issues logging in for the first time here, there's this -VV, which is the verbose command for the SSH login process, and it'll provide some debugging information. That's pretty useful for if you need to submit a ticket if you're having any issues logging into the system. You can see this is one of the links to our documentation here. There are some ways that you can tag on at the end your PIN and also get access without getting a dual push on your device. Yeah, you had a question?
SSH keys for one-time login.
For one-time login? So there's the question is one-time login for SSH. Well, so if you're logging in every single time you log in, you're going to require that login. So the authentication of the dual push. There are ways to modify, I believe it's your SSH config file to keep alive, so you wouldn't necessarily have to do a dual push. I believe there's a resource for that in our documentation, but I'll have to double check. You can explore that. So here's an example of when you would log into Casper for the first time. I think what I'll do at this point is I'll just go and show logging in here if you want to follow in. So as you can see, I get the NCAR 2-factor prompt, and this is where I enter my password. I've received the dual push. At this point, we've logged in, and what you'll see for the first time is it'll place you in the default home directory or file space. So from there, it's important to recognize that once you're logged in and you're on these login nodes, that these are shared resources. So the utilization of these, if you're going to be running something really computationally or memory intensive, you're going to impact other people on these login nodes. So try and keep what you're doing on the login nodes to reading and writing text, compiling small programs, doing small data transfers, or just submitting jobs so you're not utilizing the login nodes. If you do end up abusing the login node systems, on Derecho, we have an automated system that will send you an email kind of telling you what process is using a lot of CPU or memory. And that's a good indicator that, that type of workflow should probably be put on one of the CPU or GPU nodes. Also on Casper, there's instances where the utilization of the login nodes is excessive, and sometimes we'll actually kill those processes. But typically that's not a problem, but it's just good to be aware that anything that you're doing on login nodes will actually have an effect on other people that are using those nodes. So for something like compiling WRF, that would definitely be something where you would want to submit a PBS batch job for that. And I think WRF actually has some capability to do that using Q command, but we'll cover stuff like that when you actually start your job submission. And I'll go over that in a few slides here. But yeah, anything computationally intensive like those big compilations, it's better than not to just run those on compute nodes. And I'll talk about interactive nodes and how you kind of have the login node experience, but on a compute node. That might make compilation for these applications a little bit easier, especially if you're in that experimentation stage. So once you log in, I showed that you enter into the home directory, the home file space, and there are a few different file spaces that you should be aware of. Each have different purposes, but it's not like you have to use these exactly in the way that they're set up here. You can kind of determine what the best utilization for these different file spaces are depending on your workflow. But I can kind of go over things that you should consider when keeping data in different locations. And first with the home directory, it's a smaller file space, but the big difference here is that there are backups for the files in this system. I'll show on the next slide how you can view different states of your home directory at different times. It regularly just saves that state of your home directory so you can recover files if you delete something. You'll see below that is the work directory. Most of the time, this is going to be used for code that you've compiled and you would like to keep, but you don't necessarily need to worry about having that model backed up permanently. A lot of the times, something like using like a Git repo and running some code that way would be something I'd use the workspace for. That's 2 terabytes of space, so jump up in space. And then looking at Scratch, this is more of just a temporary workspace where you can put a lot of your output logs or download some observational data that you might be using for some runs that you're using. The big thing to note here is that it's 30 terabytes of space, so a good amount of space compared to the other file spaces. But this is not backed up, and it's also purged. So the retention policy on Scratch is that after 180 days, we remove something that hasn't been used in that time period. So if you haven't touched some data in 180 days, there's a process that we use to delete that, so it frees up the Scratch storage space. Campaign storage, that's even on a longer scale. That's used typically for like a research scale data retention, where if you were publishing a paper and you wanted to keep data for reproducibility purposes, that's where you'd want to store a campaign, store a campaign there. So one of the tools, and I have an example of this, is Gleg Quota. And you can use that command from the login nodes and it'll give you an idea of how much storage space you have. So it'll give you percentages and all that information. So the question, I saw that in chat, but Megan, would you be able to help out with that question in chat?
Sure, yes, I can help with that.
Thank you. So here is an example of looking at the different states that have these saved versions of your home directory. The command here is you'll just cd into your home directory and then use this snap ls command. And some of the additional arguments that you see on there are just a way to organize it. But you can just get that information from cd home and snap ls. So this, you can kind of see it has a date format. So this is an example of, 2023, September 20th, and the different hours that it saved as backup. So if you wanted to go and look at the files that you had available at that time, all you would do is you would either ls and get an idea of that snapshot at that time, and then you can just copy your boot files from that directory into your current home directory. And that's how the file recovery process works. But we're happy to help if you ever are missing a file and need any help with moving that over. We're also very happy to help with something like that. So here's an example output of the Glade quota command, and you can kind of see here in those top 3 Glade spaces, there's the scratch, work, and home directories, and you can just see what the percentage is full, how many files you have, how much data you use. So this is just a really good idea. If you ever run into issues and you're on like Jupyter Hub or something and you see that you can't write files, this is kind of a good place to look and see if your storage space is full. But just a good idea to keep, particularly on your home directory. To keep those below the quota limit. So for campaign storage, as I mentioned, this is kind of on the publication timescales, and there are different ways to access this data. For Casper, you can access it directly from Derecho. We have these data access nodes. If you ever need to get data from campaign, you actually log into data access nodes and you get the information that way. We also have an online tool called Globus that I'll go into a little bit more detail when we talk about transferring data to and from the systems, particularly if you wanted to transfer to your local system. And you can use that as a nice web interface that usually works. This is allocated by your project. And so this is a little bit different. So if you were to request an allocation and you had a project idea, that would be granted to you in this process, where once you have an account, you have your home, scratch, and work file spaces created for you. One thing to note about campaign storage spaces, these are compressed after 6 months of creation. So this typically isn't a great place to just store files like you would on your scratch storage space, because there can be a really big performance hit if you're trying to read or write, move around files that are in a compressed state. Other thing to note is that we have some resources available here. If you have a model and you want to use existing data sets, we have the Research Data Archive, CMIP6. These are locations where you can go and find some existing data sets, easily transfers over. You can see the RDA ones exist on campaign themselves, so it's pretty easy to locate those, kind of peruse those, and transfer those if you want to. And then for data transfers themselves, for short ones, something basic like SCP or rsync is the way to do that if you want to transfer between systems or your local machine and Casper or Derecho. The equivalent on Windows would be something like PSCP. But for longer or larger data transfers, it's not really a good optimized way to transfer a ton of files using these basic file transfer methods like SCP. So something like Globus is this tool. You can log into it via globus.org is the website. And if you have an NCAR email address, you can use that to link your account. Once you get that set up, you can search for the NCAR Glade endpoint, and that'll actually allow you to browse your home directory, scratch, work, all of those things. And it's easier, I think, to see the progress of those transfers, as well as just having this nice visual GUI to click a button and transfer a file. There's also the Globus Connect Personal, which allows you to transfer data from your local computer to your machine. We have some information on the documentation on how to set these up and the step-by-step ways to do that. So once you're logged into the system, you'll probably want to start exploring what available tools you have. And so we've put a lot of effort into creating a software stack that's available on both Derecho and Casper. so that you can log in that system, and a lot of tools are going to be available to you without having to install anything. So just to list a few of those, so we have some compiler options with both of these systems. So Intel, GCC, there's NVHPC, and then Cray compiler tools. For debuggers, you've got DDT and MAP. You have some different MPI libraries, primarily Cray MPitch on Derecho, OpenMPI on Casper. There are also some IO library tools that are defaultly installed on these systems. So NetCDF, Parallel NetCDF, and HDF5. You have things like Python, R, and MATLAB that are available. And then we also just have some different tools that make it a little bit easier to operate and do certain linking for compiling applications on these systems. And there's a ton of information on what's available in the software stack, and just also kind of, how you might go about getting those set up running on the login nodes and on the compute nodes. And the next few slides, I'll go over examples. So first of all, the environment modules. I think that we can go and just look at the commands, and that'll be a better way to show how to see what modules are currently loaded, how to swap out modules, what's available, what isn't set up right now. So first command here, module list. That's going to show you the currently loaded modules. And there are default loaded modules on both Derecho and Casper. If you wanted to see what you could load on the system, you'd use module avail. And that shows you every single module or piece of software that's available on the system. If you wanted to, say, unload the Intel compiler and instead use GCC, you could use this command of module unload of Intel and then module load of GCC. And this is all done with SPAC. And so behind the scenes, it's going to take a look at dependencies of different pieces of software that are in your module environment, and it'll actually update those and reload some of the modules if it needs to. Another somewhat useful command is the swap command, where in the example that I just provided with Intel and GCC, you could instead do module swap Intel and GCC, and it'll handle that in one command. Another thing that might be useful, particularly if you're starting a new job, is the module purge command, and that'll actually unload all of the modules and get you into a default state. There's also the module save and restore command, which allows you to, if you were to set up a specific application that need a set of modules, and you wanted to use that set of modules every single time you ran that application, you could save that set of modules and then just restore and use module restore and then set a name for that. And the most common place for that would be someplace within like a job script, or either in like your bash RC or your startup script. That might be another place where you utilize something like that. Another command that can be useful is module spider. And that'll just give you an idea of the dependency tree of a specific module. So if you're having some difficulty in loading a specific software module that you want to get set up, you could find out what the dependencies are and what the sequence that you would need to load up specific modules to get the module you want actually loaded. So on this is an example of the module avail command. You can kind of see this is set up and organized by different types of software that's available. And I'd encourage you to just run this and kind of get an idea of what's available on the systems. One thing that I'll note here, and maybe in the next few slides, I'll talk a bit more in detail about Python and how you might run some of your Python code, because there's a specific module that's needed for Python code, but I'll go over that in a little bit more detail. So this module list command, this is the default set of modules on Derecho. This is an example of that. A lot of times you can do most of your, if you were to do some basic compilation, a lot of the NCAR environment will recognize these compiler commands and act as a wrapper and compile things. But it's important to be aware of what compiler you're using if you have an MPI library set up, just to give you an idea of what's currently loaded. This is an example of the swap command, and use my example of Intel and GCC to switch out, and then it'll give you that notification of which modules were reloaded. And then you can just confirm with your module list again that you have the new version of the compiler loaded properly. I think I kind of touched on this before, but just ideally, you don't put module load commands in your startup scripts. And the reason you don't want to do that is at some point, we're going to modify the software stack. And it's going to potentially load up a different set of default modules. And it can cause a lot of issues with trying to load older modules with a different default software stack. And so the way to get around this is to do this module save functionality. So load up all your modules, get it into a state that you like, and then do that module save command, give it a name, and then you can use that module restore command. So the other thing we try and make this a little bit easier is this NCAR compiler module. This is just something that makes it a little bit easier to do like the linking and allows the include files in these compilation steps that handles it for you. So if you do a module purge and then you try and load up a bunch of modules yourself, it's important to remember that the NCAR compilers module is loaded as well. Otherwise, you might start seeing some errors with compilation related to the linking and include files. And one thing to note is that if you ever compile an application, you want to just generally make sure that you're running the code with the same set of modules that you compiled. Occasionally it'll work, but we see a lot of issues with this where if you were to run, say, a pre-existing compiled version of the code, and you don't specify the same exact modules that were used to compile it by someone else, you're going to get errors. So just being aware of that, best practice is to just ensure that compiled code modules are the same as the runtime modules. And another thing to note is that if you compile something on Derecho, it probably is not going to work on Casper. So just be aware that if just compiling for the system and the modules that you want to use is an important thing to recognize there. So before we move on to running jobs, I want to talk about Conda. And this is the environment that we would set up if you wanted to run Python code. And so if you take a look, and if we do like a module list here, you can see Conda is not included on this list. But if we do module avail, you can see there's this Conda module. And if we go and do module load Conda, now we can see Conda is loaded. What this allows for us to do is this is like if you were to use pip or something to try and install Python packages. This is the way that you can create your own environment on our systems and install things like NumPy, Matplotlib, TensorFlow, PyTorch, all those sorts of different packages in Python. So once you have Conda loaded and it shows up in this module list, you can query Conda and you can set up environments. So if for example, you wanted to use an environment that we set up, which is called MPL, you could just do Conda activate. And so we do Conda activate MPL. This gives you an idea of the available packages within this environment. And you'll find a lot of this is just oriented towards earth science specific tools and packages within this. And it's a pretty comprehensive list. And so as you start looking through this, see something like Scikit, maybe some recognizable packages in here. NumPy is in here. Numba, there's NumPy. So gets you an idea. There's a lot of packages in here. And for most folks, like this is good enough for science type of applications. But you might be interested in setting up a smaller environment yourself. And to do that, you do this conda env and then query it with the help message. You can get an idea. You can create an environment yourself. So if you wanted to conda create, or sorry, create.
And
Is that what it is?
yeah,
That's tough.
and yes, that thing. Conduct create, no, remove env. We don't need env, conduct create.
Is it just create?
Yes.
There you go. Thank you. There you go. Interactive. Well, all right. So I don't think we'll wait for this to fit, but this would, you could activate now this TensorFlow environment and start installing packages yourself. So I just wanted to cover that. I'm sure a lot of you will be working with Python. So, all right. So to run jobs on the compute nodes, we use a scheduler system, and this is the Altair PBS Pro scheduler. An equivalent would be Slurm if you've used that or seen that at all. But this is just a way for the login nodes to determine how to set up your compute node process. So this is where you would define how many resources you want to use, how many nodes, how many CPUs. If you wanted to use a GPU node, this is the tool that you use. And you'll also have to set up, we'll go over all of the parameters that you set up, but you'll have to specify wall time, like how long you want the job to run. And this will use core hours. And it's important that we recognize that core hours go against your project allocation. So to be mindful of how many cores you're using for your specific problem, we'll just save you some core hours in the long run, allow you to run more code within that project allocation. And you can view the status of those projects and how many cores you're using in SAM. So here's an example script. If you were to create this basic MPI Derecho.pbs file, the first few lines here are the parameters that you need to enter to define how many resources, the job name, the output file that you want to set that to. And so anytime you see this directive of that pound PBS, that is a PBS directive. And so, for example, -n is the name of the job. So if you were to query the jobs that you have in the system, you would see that as the job name. -o is the output file. So all of the data that you output with your code would go to that file. -a is your project code. And this -j flag would be to merge the output and error files. This just makes it a little bit easier if you run into any errors to identify where those are in the code. So it's kind of a quality of life feature on there. An important parameter here is the -q, which is the queue you'd like to submit to. And so for Derecho, that would be the main or the develop queue. And for Casper, you have the Casper queue. So below that is the next line is the -l, which is the actual resource selection statement. And in this example, when you see select in this formatting, select equals 2 means that we're actually going to request 2 nodes. And beyond that, you can see there's requesting the number of CPUs, the number of MPI processes, and then the number of OMP threads. There's also an option on here with number of GPUs, but that's not in this example. That's another slide here, slides forward. But it's important here that you see when you select 2 nodes, each node has 128 CPUs. So you wouldn't want to do, let me select 2 nodes and 256 CPUs because there are no resources available. So it's the number of nodes and then each node, how many resources you're requesting. And that's kind of the formatting of how you want to request things. Best practice here too is to do a module load within the job script here. So by default, the compute nodes will launch your job and it'll load that default module set. So if you're working on the login nodes and you've loaded a bunch of modules and then you finally launch the job and you want to run it on a compute node, it won't use those same modules. So you need to specify the module loads. You can confirm that. You can see you just have a confirmation with a module list as a command on here as well. The command above it, I'll just say it's not too much to worry about. That temp directory is now set default when you log in. There's also this command that personally I don't use, but you can query the environment by setting up some of these commands to parse the state of the job and get an idea of how PBS has set it up and what MPI processes are available in the threads. But to actually launch your job, within this script, you need a command to do whatever you actually want to run. So in this example, we're running an MPI application. It might be here that you're running Python, or that might be the command. But in this example, MPI exec is utilizing a total number of 256 processors, and then the dash, I think it's processors per node is 128. So you can see that maps to what we requested with that PBS statement. And then just running the application. So here's another example if you were to request GPUs, and probably the big difference here is that just the select statement is the MPI prox is equal to the number of GPUs that you're requesting. That is a pretty good practice. That'll allow the GPUs to communicate with each other for most applications at least. But specifying the number of GPUs here is how to get a GPU node. There's also something that isn't shown here that on Casper, you can specify a GPU type. So if you wanted to use a H100 instead of a V100, for example, you would append to the end of this PBS select statement, -L, and then GPU type equals A100 or V100. And we have some more examples of these job scripts in the documentation here, if you want to take a look. And it's a really good way to kind of just get a starting point for the types of workflows that you might have. So to actually submit that job script, so they call that script like a command file. So to actually launch this from the login nodes, the default command to do a batch job would be this qsub and then the script parameter name. So this will submit it to the scheduler itself. And after a little bit of time, you can actually query that job to see if it's running using the qstat command. And I think in the next slide, there's an example of how you can just query that using your username, and it'll show all of the jobs that you currently have running as your user. There's this other interactive type job that I briefly mentioned before. And if you wanted to, for example, just have the same login node experience, but have it on a compute node, the interactive job is the way to do that. So there's this Q interactive command. And you'll have to supply the same parameters. So you have to, by default, you provide a -A, which is your project code. And that's, I think, the minimum set that's required for this. There are default parameters that'll provide you with like wall time, the number of resources for this type of command. You can also submit a interactive job with qsub. If you were to do qsub -I, capital I, that's also an interactive job. So there are a couple of ways to do that. And there's examples of that in documentation as well. Sometimes you'll see this Q command operation, and this is often used in, I think it's in CSM WRF, but it gets used to simplify the process for launching a job. It'll just use a default set of resources to launch a job. And then if your job's complete and you were curious how many like what was the CPU utilization, how much memory it used, you can take a look at the history of jobs you have using this qhist command. And there's that qhist --help argument that'll give you all of the options that are available. You can provide a little bit more information. You can sort by user. You can have date ranges available in this tool, and it's pretty powerful for seeing what jobs you've run for time. So here's the example of running this basic PBS script. And you can see at the very top, it's this qsub basic PBS script that we're running. And once you submit that, it'll give you the job ID and then followed by the schedule of there that actually ran. So this example is running on Derecho. You can see that qstat-u user command is just going to query jobs that are started by you. And you can get an idea. I think of note is the runtime probably, and the state or the S column. The Q would be, it's in the queued state, so it's waiting to actually start running. If you were to see it in the R state, that means it's running. You can get some more information about behavior of your job using this command. And then if you have a job that's hung or just isn't seemingly running properly, then there's the option to qdel, which is you use the job ID that was created for you and you just delete that job and it'll remove it from the queue. And then there's an example here of that qhist command that shows what types of job you ran, the GPU and the CPU utilization, the time it took to run, And you can do some additional querying using QS. There's also an option of doing something that's called cross submission. So if you were running something on Derecho and you, let's say, for example, you have a simple script that only needs to run on one CPU, but you don't want to use Derecho and use 128 core hours, for example. Cross submission would be something where you could launch your script from Derecho, but target the Casper scheduler. So this example, you queue sub to the queue Casper at Casper-PBS. That's telling it to submit it to the Casper queue scheduler, and then your job submission script. And then looks like here, another example, this example pointing out a single node job that only uses OpenMP. And so you can see the select statement is highlighted here. We're selecting one node, 24 CPUs. We'd only have one MPI processor, and then 24 OpenMP threads. This is just a slightly different way to request a job with a different workflow. At the end of that, you'll notice there's the mem flag or parameter for the select statement. That is how if you wanted to target a large memory node, you would specify the amount of memory that you need. Or if you know that your code needs 235 gigabytes of memory, you could specify that here, and it would ensure that it would allocate that much. I guess one thing to also point out is that if you're requesting a lot of really big jobs or jobs that request a ton of memory, the schedule starts to recognize that. And so there's this fair use policy with the queue scheduler that if you're launching a bunch of jobs, eventually your queue might take a little bit longer to launch some jobs. And that might also explain, when the system's kind of busy, why initially you wait in the queue for a little bit, but then 30 minutes later, that kind of alleviates itself because maybe someone submitted a couple huge jobs on the nodes and it just takes a while to sort that out. All right, and so some of the, particularly on Casper, there's some data analysis tools. So this would be used, for example, if you wanted to use MATLAB, R, or if you wanted to look at like a tensor board, something that required you to get outside of the command line interface workflow that we have on the supercomputers. And we have a couple different ways to make that a little bit easier. One of those is VNC. So there's this command within Casper is VNC manager command. And this will launch up this session and connect you up to a GPU using this Turbo VNC or Tiger VNC method. And this is just a slightly better way to connect up and have faster response than if you were to just do like X forwarding. Something that I also really like to use here, this requires only a web browser. You can log in for this fastx.ucar.edu and then the port number of this website. And you can get a session, this website, and a little bit better response to connect up to Glade. You can run a terminal, you get a nice GUI. It's a little bit more of like what you'd be familiar if you had a laptop that was running Linux. One thing here is that you'd have to be connected to the NCAR VPN to access this. And just there's a couple different options of types of OS essentially that you'd like to run using this. So here's an example of once you've connected up in your web browser, you could, for example, look at a PDF or open up MATLAB. You'd have to do a module load of MATLAB, and you could run MATLAB from the terminal, and it'll give you this nice GUI. Another example of just editing some files within the GUI. So one other part here is Jupyter Hub, which is utilized quite a bit and it's gaining in popularity at NCAR here. And we have a site where you can request a Jupyter Hub session. And this allows you access to Jupyter notebooks. We also have quite a few kernels set up that allow you to have Python packages that are installed. And you can run a lot of your code interactively in this environment. So going to this website, jupyterhub.hpc.ucar.edu, gives you the available resources, and production would get you into this next window where you have the ability to create a new server. And you can create this server. Once you do, I'd recommend naming your server. You can it's a little bit small on the screen, but you can see there's an option to name your server and then add a new server. You can create that. There's an action button. You create that new server. You can start the server. And from there, you have a couple different options of how you would like to run your notebooks. So this dropdown right now is showing the Casper login node option. This would create a Jupyter Hub session on a Casper login node. And so the same limitations of the login nodes apply here. If you're going to be running a really massive notebook, you probably don't want to be requesting the login nodes. So this would be, if you're editing the notebook, you're running a couple small cells, things like that. Within that dropdown, there's an option to do Casper PBS batch and then Derecho PBS batch, and those will actually launch your server on the compute nodes. So that'd be the place where if you're running some really big notebooks, you'd be requesting those types of resources. So once you are able to connect up and get a session, the default login here should place you in your home directory, and you'll have access to the file manager on the left, and then on the right side, this launcher window. And from here, you can kind of see there's some different environments that you can click on. So for example, there's the NPL environment. If you were to click on that, that's equivalent to if that example I showed you in Conda of activating a Conda environment, all of those Python packages would be available to you within your Jupyter notebooks. There's also the option to run terminals within here, so it's a pretty robust system here. So here's an example of just running some of the cells. This is an example notebook, and you can see you can import some of the packages, and it's kind of the same syntax, but split out with your Python code. There's really good visualization options. I'm sure many of you have used notebooks before, but this is just a really good way for you to get the resources available, but also have access to all of your files within the Glade file system. So I think that's about what I have to cover here. The other thing here is that documentation is a really great resource to expand upon pretty much everything that I've discussed here today. There are links within the slides that if you'd like to follow those, it'll give you more specifics and details about that information. There's a lot more that you can just kind of look around and get a better idea of some of the tools and resources available on those systems. So the other resource available is the CISL Help Desk, and this is the Research Computing Help Desk. So if you have a problem with your Conda environment isn't running the Python packages you thought, or you're not sure how many resources to request for your job that you're running on a compute node, this would be the place to submit those sorts of tickets. We also have the option of a few different tutorials. We ran a GPU workshop tutorial a little while back. There's also information about Dask, different storage spaces, and more detail. So there's plenty to explore there. And then just a little bit of information about how to submit support tickets and what information probably will get you, the quickest response and easiest time to resolution on those. So resource name, what are you running on? The error messages. If you have a script, what is that script? If you had a job ID that failed, or you were interested to figure out more about what's that job ID, and then any sort of paths or information that you can provide be helpful for resolving those issues. Another option here too is if you prefer to do something, either face to face, we have that option where you can schedule that, or virtually. You can also set up a session. There are quite a few of these different support scheduling portals available with different experts, depending on what you're interested in. But if you wanted to, have something more face to face, or you have a specific problem you want to talk it out, this is a good way to do it. That is also available. Let's see if we have a link. I don't think we have a link for that, but that's available on our documentation page as well. So here are some links to a few other resources. There's the NCAR HPC user group Slack channel, which we monitor. And if you have a problem and you just want to reach out via Slack, that's a really good resource that we monitor. All the time. So I think that's all I have to cover. Do we have questions about running jobs or specific application workflows that anyone's curious about? Yeah.
What would happen with, if I just run a executable into Scratch? directory? Like what would happen?
So running executable in Scratch, I mean, that wouldn't be any different than running an executable in the work directory. So there are some differences when it comes to the actual structure of the file spaces. One's Lustre, there's a different type of file spaces, but I think you'd have to get into a really involved workflow to have to worry about that too much.
Okay.
The general recommendation is if you have applications, you compile and run them on work, but there's really no concrete rule on how to do that. So Scratch, run an application.
Yeah, like the reason that like I'm like asking is because like if I wanted to first, write my code, right? Like I first do it on like a small scale to, to be sure that, like it's correct. And then I'll like scale it up and then like send it to do the job. So is it fine? Like if I just like run the code in the Scratch directory from
Yeah.
the beginning?
Yes.
Okay. Great.
I do that quite often. So the one thing you just need to be aware of is that will be purged if you don't use those files for 180 days. So
Okay.
it's something you might think you want to keep and you don't have anything like a Git repo set up for that code, then you just need to be very aware that, yeah, that is a temporary file space. And that is the one risk and why usually we recommend that you just run those applications themselves within work.
So we saw that we have different storage systems, like we have work, we have Scratch, we have campaign. So do we have any in terms of read and write speed? Are there any advantages of one versus another? Like if I use Scratch, for example, would I get a faster read and write speed than the campaign?
So we've seen some examples of, based on the different technologies used for these spaces, that there can be, but I would say that for most workflows, no. The only file space that you need to be aware of is campaign. That would be the one that you would not want to be doing a lot of read and write operations out of.
So that's why I actually asked the question, because most of the largest scale data are stored in the campaign.
Right.
So if I want to use them, and for example, some of them are like hundreds of terabytes. So is it recommended to make a copy of them to someone's Scratch directory? And like that would be kind of like a duplication. But I think it's still worth it because you are getting the speed bump in terms of operations. So what would be the most recommended way of?
So I'd have to check and see because I'm not entirely sure on for campaign storage, there's compression after a certain time period. So I don't know the specific data sets that you would be referencing in your code. If those get used quite often, if those actually end up getting compressed. But I think that best practice would be if you can fit the data set within Scratch, that's the way to do it. If you're concerned about the storage limitations within Scratch, there are actually options to expand that. So you can request additional Scratch storage space. Typically, we do a finite time for that. But yeah, there are options for that if you wanted to have your own copy of it.
So last week I was using someone else's data that was generated in 2022. That's way beyond in the past. And it took me 7 hours just to copy their data from their the campaign storage to my Scratch directory. So that's where I actually came to suspect that the read and write speed are very slow where the data is currently at.
Right. Yeah, and I do know that at least from what I've seen that if you can get those files copied and have your own version, that's ideal. But obviously, as you understand, you're limited by the size.
Yeah.
And if those are very large data sets, then I think that's a case where you would reach out via Slack or the help desk and see what the best option is.
Okay,
for
got it.
that. Yeah.
Thank you.
Do you guys possibly have tutorials or something to see how to connect, like from the database to like Jupyter Hub or something to read it? You know what I mean?
So you're asking if we have tutorials on the process,
Yeah,
so that connect up to Jupyter Hub or
yeah, from the database. If like we were given like a connection.
so if you wanted to connect up to Jupyter Hub specifically, That's via the web interface.
Yeah, but I,
So the database, you mean like Glade and all the files that are available,
yeah,
the computing systems?
yeah, because I was given access to a database and I want to be able to use it, in my code
Mhm.
in Jupyter Hub.
Sure.
So I know there's like libraries and stuff that I can use to connect. But do you guys have tutorials possible for that?
Maybe not to this specific instance. I think we'd have to look and see where that database is located. If it is on Glade, then yes, we have tutorials on how to launch that instance. And I think the documentation link, let's see if I have that the link that's on here for our documentation page. If you were to look for example, Jupyter Hub, you'd be able to find documentation and kind of a walkthrough on how to set up and log in and do that for the first time. But for your specific instance, I think that's up. Yeah, just reach out to us and we'll make sure that that day is available.
This space where you can search. You got knowledge space. So this should be your first place to search.
All right, let's see. Megan, I don't know if we had any additional questions online.
No, I don't. I think I've answered all the questions. There is one user who's asking about Jupyter Hub sessions, and from just checking their account, it seems like they are currently actually running one Jupyter Hub login session. So that might be the reason that their login session crashes. But yeah, other than that, there weren't any other questions. That's unanswered.
All right. Thanks so much, Megan.
Sure, for sure.
Okay. Well, looks like we finished up a little bit early, but I think if y'all have any questions, in addition, I'll be hanging out for a little bit longer.
I have some more questions.